If you can dream it, we can help you create it. Welcome to the You Create podcast, the show that teaches you how to take the power and flexibility of a Stepcraft 3D CNC system and turn your ideas into reality. So let your ideas flow, because we want to know, what will you create?
Welcome to episode 11 of the You Create podcast. My name is Eric and I'm your host this week, and I want to thank you for joining me again for another great episode of the You Create podcast, the podcast that's dedicated to CNC, 3D printing, makers, and business. Last week I talked to you about a model railroad show that's coming up in West Springfield, Massachusetts at the end of January, and another one of our listeners had brought another show to my attention, and I don't know a lot about it, and I was hoping to reach out to you, our listeners, to see if you have any familiarity with a show called the Cabin Fever Expo. And it is scheduled for January 15th and through 17th of this year, so in a couple of weeks, in Lebanon, Pennsylvania. Now, it looks like it's a show that is dedicated to model engineering, where I guess people are designing things like steam-powered model cars and model engines and, different things like that. Kind of like a high-end maker fair, I guess, from what I'm reading here. And I don't know much about it. I really was thinking about trying to attend it with Stepcraft, maybe to have a booth there to see if we can find new potential prospects for our machines. And I did look, and I know Tormach has a booth there. Of course, their machine is a lot more expensive, and it's a dedicated CNC mill, which is primarily for working with just metals and stuff. So that's maybe more in line with the show, but I don't know a lot about it. I'm doing some research now, so I wanted to ask you, our listeners, if you have ever attended or know anybody who's attended. I'd love to know some more information about it to see if it's worth traveling down to Pennsylvania to get a booth there. It looks like it'll be cool. It looks like it'd be a really cool show just to attend, but I'm trying to reach out to them too to find out. It looks like there is some booth space left, and I would like to consider getting into there. So please email me at info@stepcraft.us or call me at 203-556-1856 if you know anything about this show. I'd really appreciate hearing from you. So this week I wanted to talk about a new product that we had just released, and it's a heated bed for all of our machines, and it's for use with the 3D print head. Now, a little bit about why you might need a heated bed with 3D printing. So back in the day, and I've been 3D printing for many years now, so I know an awful lot about it. And I've used all kinds of filaments, and I've had many, many printers. One of my favorite printers that I have that's a dedicated printer is by a company called Ultimaker. It's an Ultimaker 2. It's a pretty fast printer, has about a 9x9 build volume on it. It works really well with PLA. It does have a heated bed, so it will do ABS. It uses a SD card reader, so it's not tethered to a computer, which is kind of nice. The downside with this printer is that it's $2,500. That's a lot of money to spend on a dedicated 3D printer that you can't do anything else with. And because of that, because when you look into the high-end printer market, or even the lower end, like the Dremel 3D printer that they just started selling, is still $1,000 by itself. Now, a lot of times, you're if you got into CNC because you like milling, cutting, carving, things like that, that's great. But there are always cases where, you'll have a job that you kind of wish you can do in 3D printed. Maybe it's better served done in plastic. Maybe it's a complex part that would be very difficult to machine. Or maybe it's just something simple that you want, like a bag clip for potato chips to keep them closed that you find off of thingiverse.com. And if whatever the case, it's nice to have the flexibility in your shop to be able to do 3D printing. And that's where Stepcraft kind of comes in. We're one of the only machines on the market that has all the universal attachments in a CNC. And the fact that you can, quickly and effortlessly take a spindle off and put a 3D print head on, and now you're essentially building parts from nothing using a 3D printer, you have that ability without having to spend thousands of dollars on a separate machine. Now, our 3D print head's $599, which is significantly less. Even if you were looking at the Dremel machine, which is $1,000, it's still $400 more, and it's a standalone machine. So if you're looking to do a lot of different things and using a spindle and doing CNC woodworking and things as your primary, but you'd like to have the ability to do 3D printing as well, that's where we come into play. Now, if you're a 3D printing prototyping shop, say where 99% of the work you're going to do is 3D printed, then you might be better served with a standalone 3D printer. But where we came into play is for those people that want the flexibility to do a lot of different things, but don't want to have to spend huge amounts of money buying specific machines for each one of those tasks. So that's one of our advantages. Now, in 3D printing, there's two types of feed systems. The Stepcraft uses a stepper motor, which is a direct feed. So the stepper motor is located directly above the heated element, and it essentially pulls the filament and feeds it in a straight path directly into the heated element. Now, why is that important? Well, the other type of 3D print system is called a Bowden, and it's even the Ultimaker that I have is a Bowden system. And basically, it puts the stepper motor on the back of the machine, and the stepper motor pushes the filament through a long tube into the heated element. Now, because there are so many different PLA filaments that are out there now, there's magnetic, there's conductive, there's rubber-based, there's metal-based, there's carbon infused. There's a lot of custom PLAs that give you a ton of flexibility to do all kinds of different things with a 3D printed part. And the one problem with that is not all printers can feed these materials. Now, I'll give you an example. One material that we got in here is called Ninja Flex. It's a rubber-based PLA, and it will not print on the Ultimaker at all because typical filament from PLA and ABS is rigid, almost like a wire, like a plastic wire. So when the machine uses a Bowden and it's pushing the filament, it goes in, it's stiff, so it has no problem feeding, and when it has to retract, it pulls back and everything is fine. The rubberized PLA, because it's rubber-based, when you try to feed it and push it, when it meets resistance, it starts to buckle inside of the tube, causing a not so accurate print, and it causes a lot of trouble. So on the Stepcraft machine, because the stepper is directly above the heated element, we've run and tested all of these different filaments, all successful. We have the ability to retract and push material in because it's right there. There's no tube. We don't have to worry about binding or buckling. The design is very, very simple, but it works extremely well. Now, I mentioned retraction and why that's important. Say you're printing a part like a box. Let's just say a 1-inch square box, and it has 2 millimeter sidewalls. Now, when you're printing, if the print head has to move from one wall to the other, where it travels across an open space where it's not printing, it has to retract the filament in order to not continue to print it. The best way I can describe it is think of a caulking gun that you would have with the squeeze handle with the ratchet thing. So you put a tube of liquid nails or silicone into a caulking gun, and you cut the end and you start to feed it. Now, when you're feeding it, you're squeezing the handle and it's putting pressure in the tube, and that's what's ejecting out the silicone and to your work area. Now, when you're done, when you reach the end, if you don't push that little tab on the back to release the pressure, then what happens? The filament the silicone will just keep pouring out because it's pressurized, and that creates a mess. And it's not something you want to have done. So what you'll do is when you reach the end, you push that little tab in, that releases the pressure from the plunger, and that essentially lets you pull the caulking gun away and not have material keep coming out. Well, a 3D printer is exactly the same way. When you go to retract, so when you move the head across a space where you're not printing, you have the stepper motor will actually retract. It'll go backwards a preset distance, maybe a couple millimeters. And what that does is it pulls the filament out of the heated end, which stops it from coming out and printing. If you don't have that, what ends up happening is you'll end up getting a series of really fine webs, kind of like you'd experience with a hot glue gun. You know, when you glue something with a hot glue gun and you pull it away, you get those really fine lines of glue. Same thing happens with a 3D print head. So the ability to retract the material with a custom material like the rubberized PLA, the Ninja Flex and stuff, having the stepper motor at the head is always better because you have a much more positive control over the amount of filament that's being retracted and pushed back out. And it works a lot better on a material like that than the Bowden design. So that's one huge advantage that we have. Now, the disadvantage Stepcraft has had up until this point is that we had no heated bed. The 3D printer would come with a piece of plexiglass that you would attach to the surface of your Stepcraft machine, and you can either print right on this plexi, or some people would put blue 3M painter's tape down and print on top of that, which works really well. And that's great for PLA because PLA doesn't require a heated bed, and even all the fancy PLAs don't require it. So you don't necessarily need a heated bed for that. However, if you want to use ABS, then ABS has a tendency, as it cools, it curls. So it kind of contracts a little and it causes the edges to curl. So if you were trying to print a part that was 2 inches square flat, you'll notice that as the part starts to cool, the edges are going to curl up, which may render the part useless. Now, the thing with 3D print technology is it's not super fast. Nobody buys a 3D printer because they want to knock off a part in 30 seconds. So, you may have a part that may have an estimated 4-hour print time. And it really stinks when you go to look at the part an hour and a half into it and you realize that the edges, all the corners are curling up off the surface, and you just wasted an hour and a half and some material and you can't use that part. So I've had a lot of success with ABS on a Stepcraft without a heated bed, but it's kind of a pain. There's certain things that people try. You can read online. Some people will use like Aquanet aerosol hairspray and spray that down on the surface, which kind of acts like a glue to the ABS as it's coming out. I've had success making a slurry, which basically is taking pieces of ABS and mixing it with a couple tablespoons of acetone. And what it does, it breaks down the ABS, and then you use a disposable paintbrush and paint the slurry onto your work surface. And then once it dries, you start 3D printing. That's worked well on the Stepcraft machine. For me, there are some downsides. One, it smells. It's almost impossible to take the part off of the work surface, especially if you're using blue painter's tape. You'll expect that the tape is probably going to peel off on the bottom of the part. If you have a part that you don't care about the bottom, or maybe you can sand it off, that's probably not a big deal. But the better solution is to have a heated bed. I mean, if you have a heated bed, what happens there is you're controlling the cooling temperature and you're keeping the bed warm, which keeps the bottom of the material warm and stable, so that it has less chance of curling up as it cools. It does help. It helps a lot, actually. And that was one thing we were missing up until now, and we just released our heated bed. So for those of you that want to do 3D printing and want to use ABS, you have that ability now by adding the heated bed, which has about a 10 by 10 inch work surface, and you can just simply fix it down using double-sided tape or the crossbars on the Stepcraft, or using a T-slot table with clamps to hold it in place. Plug it in, set the temperature you want, start printing. Now, the heated bed also helps and does work with PLA as well. You won't use as high of a temperature, but it doesn't hurt to have the bed warm as you're laying PLA down. It will keep the material flat regardless, but it's one of those things that you don't necessarily need it with PLA, but it doesn't hurt. And in some of the custom PLAs, like especially the metal infused one, a heated bed does work a little bit better and makes it easier to remove the part later, where it doesn't stick as solid as it would to a piece of plexi or the blue painter's tape. So it's a great option. It's the one thing we've been missing in the 3D print arena, and now we have it. So if you do need to print ABS, or you have an application where you need the heated bed, then we now have that. Now, a lot of people ask me, why do I want ABS? See, whenever we go to a show, people ask, well, do you have a heated bed? It's funny when they ask that, because for the longest time, that's always been a selling point on a 3D printer. PLA has been was not used as much, especially when it comes to making a part that's really strong and has rigidity and durability to it. ABS tends to be a preferred plastic for that. ABS has some negatives. I mean, the curling and the difficulty getting it to stick is certainly one. The fact that it emits an odor like burning plastic when it's being printed is another. However, now with the new PLAs that are out there, there's actually PLA material now that's a lot more rigid and durable and flexible than ABS. Carbon infused PLA is a good example. You could build a little quadcopter out of that and have it be extremely rigid because it has carbon fiber built into the material. Now, the one downside with PLA is you build a black cell phone holder for your car and you put your cell phone in it and you run into the store and it's a 100-degree day and you got your windows closed. There is a possibility when you come back out that the weight from the cell phone may have distorted your holder, because PLA has a lower temperature resistance as far as what it'll take to get it to become malleable again, where ABS is a lot higher. So there are still some cases where ABS is a preferred material. And now that we have the heated bed, you have the ability to utilize that as well. We're going to talk more about different materials and stuff in a future episode. I do want to talk more about 3D printing. We have a lot of attachments and stuff for the Stepcraft, so there's always different things to talk about. It's not always CNC work, but that's one of the beauty of our machines, and that's kind of why we call this the You Create podcast and not a CNC podcast, because there's a lot of different things to talk about. And I want to be here to answer questions. And like I said, I've got about 6 years of 3D printing experience, and I'm here to help with any kind of questions or design questions or application questions. So feel free to contact me at any time regarding that. But you can go to stepcraft.us and check out the heated bed. It will be on the homepage by the time this podcast airs. Okay, now we want to talk a little bit about some tech subject here, something that I've got a few emails from customers who bought machines over the last couple of weeks. And this really applies not just to our machines, but to any CNC, any gantry-based CNC machine that's out there. And it involves aligning the gantry itself. So I've had some people that were saying that they put the machine together, everything was all set, and when they went to move the y-axis, it wouldn't move. It would bind, or it would move a little bit and then stop. And they can hear the motor humming, or they just couldn't get it to move freely. So you start the troubleshooting process in that, and I want to say 99% of them, it turned out that the gantry itself was not properly aligned. The left and right side were actually off a little bit, which causes the gantry to skew. So when the motors try to move them forward, it binds. You got to remember that the tolerances that the gantries are usually set up at are very precise. And whether it's a track rail system or a linear slide bearing, you need both the left and right gantry upright to be in alignment in order for the motor to be able to move it freely without excess stress, and to allow it to move completely from the front to the back of the machine without binding. So the easiest way to do this, and again, this applies to all CNC machines, especially those of you that are home building machines, but specifically to our Stepcraft machine. On our machine, we have a lead screw that we use on either side that controls the upright for the gantry. And it's connected in the back of the machine by a belt and then to a motor. So a single motor, uses a belt to drive both lead screws. Well, what you need to do first is take the belt off so that you can independently move the left and right lead screw and the gantry itself independently. Now, what you're going to do is you're going to manually move the gantry to the back of the machine. And usually we tell people to use the feet that we give you, their plastic feet to support the machine. We tell you to use each foot. So you put a foot in on each side between the back side of the gantry upright and the front side of the back plate on the machine. And basically the foot is acting as a spacer. And because they're exactly the same size, you can use a foot on the left and the right. And you're going to manually turn the lead screw until the gantry is touching the plastic foot and it remains in place without you having to hold it there. Then you're going to do the other side and you're going to do exactly the same thing. At this point, you know that the gantry is in exactly the same spot on both the left and right side. Now, you don't have to use a plastic foot. I mean, we've used aluminum block. We've used whatever you use. You just want to make sure that A, it's solid, it's not squishy, and you want to make sure that it's the same thickness on both sides. So whatever you're going to use, if it's an aluminum block, make sure you have two of them that are exactly the same thickness. And that's pretty much it. Once you set the gantry so that it's even, then you reattach the belt. Or if in your case it's your machine uses a rack and pinion or so, whatever the mechanical tie it is to tie the left and right side together, at that point you're going to re-engage it. Now, if it's a bigger CNC or if it's a CNC that uses an independent motor for both sides of the gantry, then at that point, once you adjust it, then you'll reapply power to the machine, and both sides of the gantry, when the motors move, they're going to move in sync, and your gantry should be square. You'll want to make sure that you have proper lubrication on both sides of the gantry so that if you're doing this for the first time, you might want to put a little bit extra lube on there so that when you move it all the way to the front and back, you're lubing up the tracks and the bearings and everything for the entire length of the machine. So that's pretty much it. Now, if you're still having issues with it binding, then you got to look at some other stuff. Make sure that your track rollers are straight. Make sure that your lead screws are not bent. Make sure that, whatever the track system is on your machine, make sure that it's true and straight and not bent, because any deviation in that could cause binding. And you'll know this by manually moving the gantry forward. Maybe you're doing it by hand once you've got them in sync. And if you find a spot that it binds every time in its travel, perhaps there's something wrong at that exact spot on the machine. But if it's randomly binding in different spots, then you have to go and look at, okay, maybe the track rollers are too tight. You have too much tension on there. Some people have a tendency on our machines to over tighten the track rollers, thinking it's going to cause the machine to be run truer. And what it essentially is doing is it's causing more friction against the track, and it makes it harder for the motors to move, and it stalls. But the most common thing is improper alignment of the left and right gantry, and that's applicable on pretty much any gantry-based CNC router machine. Once you get past that, make sure it's properly lubed. Make sure that when the gantry sides are the same distance apart, that's when you reattach the mechanical part, whether it be the belt or whatever the drive system is on your machine. And then you go ahead and use your machine control software to automatically move the gantry front and back, and you should be in good shape without any binding. So I just wanted to bring that up because it is a common question we get. It's a very easy solution, and from reading in forums and stuff online, I know that it's a pretty common problem within the DIY people as well. So just a little tech tip for the week. Let's see. I want to finish up this podcast by answering a question that a listener or potential Stepcraft customer had brought to my attention. He says, I'm new to the CNC world and I started to do my homework by looking at what was out there. I'm an industrial designer who mostly uses SolidWorks and Illustrator. Your Stepcraft 2420 seems to be a good fit for me. Do you know if we can work directly from a file like an STL or other format used by SolidWorks? So the answer to that question is yes. And I say yes because we resell Vectric software. So that's the software that we recommend that you use with our machines. Now, you can use other CAM software that's out there. It's just that we sell and support the Vectric stuff, and it's very powerful, easy to use, and has the functionality to do just about anything that our customers want. So with Vectric, yes, you can use files from SolidWorks. However, if you're using Vectric Cut 2D, you can't use an STL file. It doesn't allow you to import a three-dimensional image format or a three-dimensional drawing. You can use DXF or DWG and work in 2D line format. Now, if you want to use an STL file or you want to use the full three-dimensional file, then you can use either VCarve Pro or Desktop, or Aspire, or you can even use Cut 3D. Now, Cut 3D is a 3D carving program, so it will accept natively STL files, and it will allow you to place that file on your work surface and choose whether you want it to be embossed or exposed or make a positive or a negative. There's a lot of settings in there that you can choose to lay out that particular file. Now, my guess is because you're an industrial designer, you're probably not talking about carving jobs where you're going to carve an image, a 3D image, onto a piece of wood, like on the top of a jewelry box or something. My guess is you're talking about machining out a working part, most likely that has two sides to it. And if that's the case, yeah, you can do that as well. It's a little bit more complicated. I'm not going to get into that in this podcast, but it involves making a fixture for the part so that you can run one half of the part and then flip it over and do the other side. And that involves creating a fixture or a jig that allows you to do that so that your XY0 is in the same spot when you flip the part over. But the short answer to the question is yes. Depending on the Vectric software that you have with the Stepcraft machine, you absolutely can use STL files or other SolidWorks or Illustrator type files. That's not a problem. It just depends on which program you're using. And if you're looking to do three-dimensional file work, then you can't use Cut 2D. You'd have to go to VCarve or Aspire or Cut 3D for that. So hopefully that answers your question. And again, that applies to anybody using Vectric software with their CNC. But we do have a lot of customers who use SolidWorks or AutoCAD or Illustrator, CorelDRAW, a lot of programs that have 3D capability. Now, the other thing is if you're using a Stepcraft machine and you want to use the 3D printer, then that software that comes with the 3D print attachment does accept STL files. That's the common format used in 3D printing. So you will use an STL file when you're using the 3D print attachment. That's just the standard. So you have that ability as well. So anyway, I want to thank everybody for joining me again in this episode. Again, for the show notes, please go to youcreatepodcast.com/011. And if you have any questions, I'd love to answer them for you on the podcast. If you have a unique story or business that you want to talk about, I'd love to have you on as a guest as well. Please feel free to call me at 203-556-1856 and press the number for sales. Or you can email me at info@stepcraft.us, and that will come to me directly, and I can answer your question from there. So as always, if you like the podcast, please, I encourage you to go to iTunes and rate us there. I would really appreciate that. That helps get the podcast ranked and exposed to more people. So that's it for this week. I look forward to serving you in the next episode. Have a great week.